Before we dive into the operation of a DC motor, let's first take a basic overview of the motor's mechanical design to understand how everything is structured and connected. First, let's focus on the field frame, the stationary part of the motor whose primary purpose is to create a constant magnetic field. It mainly consists of a yoke and a set of stator poles, which are secured using bolts. The yoke is constructed as a solid piece using a high permeability magnetic material, such as cast or rolled steel. The yoke serves as a structural backbone that holds the stator poles firmly in place and withstands mechanical stresses during operation. The yoke plays a crucial role of completing the field's magnetic circuit while also serving as a sturdy backbone that holds the field. As seen here, the magnetic field flux flows through the yoke. The magnetic polarity of each pole is opposite its adjacent. The field pole iron is composed of two parts, the pole body and the pole shoe. The pole body is the central section that carries the field winding, while the pole shoe is a wider section at the end that spreads the magnetic flux over a larger area of the armature. This helps create a more uniform magnetic field and reduces localized magnetic saturation. One or more thin sheets called shims are placed between the pole body and the yoke to finely adjust the air gap between the stator and the armature, which is critical for proper symmetry within the motor housing. The shims for the main field poles are usually made from high permeability, ferrous magnetic material. Rather than being made from solid steel, the field poles are constructed from a stack of insulated laminations made of steel, with each sheet around 0.5 mm thick. This laminated structure minimizes eddy current losses and improves the motor's overall efficiency. On both sides of the laminated stack, thick steel plates are added for mechanical stability and the entire assembly is clamped tightly using rivets to hold everything in place. In modern machines, the pole body and pole shoe are manufactured as a single laminated unit. In contrast, older machines often featured a design where the yoke and pole body were cast together as a single piece, and a laminated pole shoe was attached separately.